Hello students, today you are going to learn the introduction of matrices. Now, what is a matrix? It is nothing but it is arrangement of numbers arrange numbers in rows and columns. Rows and now the question comes, what is a row? If you have a horizontal arrangement, then that is row. If you have a vertical arrangement, then this is column. That means if you are standing goes to columns C, and if you are sleeping on the bed, then it goes to rows. That means if I keep this way, it is in row wise. If it is standing, then it is column. So this way it is column, and this way it is row. Fine. Now if I have 10 numbers, how can I possibly arrange these numbers in matrices? Obviously find the factors first of 10. 1 into 10, 2 into 5, or 5 into 2, or 10 into 1. So there are 4 possibilities with which I can arrange 10 numbers in a matrix. This 1 into 10 means there will be only one row and 10 numbers we write. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All these numbers come in a single row. This is one row and 10 columns. See, 1, 2, 3, 4, 8, 9, 10. Fine. If I write 2 into 5, then obviously my matrix is always in a bracket. Now 2 into 5 means I need to have 2 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 2 rows, 1, 2, 3, 4, 5. So 2 rows and 5 columns. So this means what? The intersection of rows and columns, wherever is the intersection of rows and columns, that is the place where we arrange the numbers. Fine. Now similarly we can keep 5 cross 2 and 10 cross 1. So if you have 24 numbers, dear students, how do you arrange 24 numbers? Then 24's factors are 1 into 24, 2 into 12, 3 into 8, 4 into 6, 6 no into 4, and similarly 8 into 3, 12 into 2, 24 into 1. So this means there are 1, 2, 3, 4 and plus 4, 8 possible ways with which you can arrange numbers in a matrix, and these are called the orders. Okay, this is one row 24 columns is the order of the matrix. Fine. Now let us go to types of matrices. The first of its kind is row matrix. Row matrix is a matrix which has only one row, say 1, 2, 3. It has one row and 3 columns. So a matrix which has single row is a row matrix. So you can write having single row. Second one is column matrix. The second one which I am showing you is column. Obviously, having single column, we have having single column. That's a column matrix. So if I write those numbers 1, 2, 3 this way, this is 3 rows but 1 column. So this is a column matrix. Then we have square matrix. A square matrix is a matrix which has equal number of rows and columns. Then comes identity matrix. Equal number of rows and columns. If you want to see the example, say there's an example 2 1 3 5. This is a matrix, so it has 2 rows and 2 columns. There can be one example of 3 cross 3 also. A B C X Y Z 1 2 3. This is a matrix which has 3 rows and 3 columns, so it is 3 cross 3 and it's a square matrix. Fine. So let us go to some other type, students. There comes one more thing. The next one is identity matrix. Identity matrix. What is identity matrix? Remember, a square matrix is an identity matrix. Its determinant value should be 1. So identity matrix has its diagonal elements 1, non-diagonal 0. If this also can be written as I2. I2 means a matrix with order 2. There can be an identity matrix with 3 rows and 3 columns. So see, this is a matrix which has 3 rows and 3 columns. This is a matrix denoted as I3, identity matrix of order 3. If you have a matrix whose diagonal elements are non-zero, say diagonal elements are non-zero, say this is 2, 3, and non-diagonal elements are 0, then this is called diagonal matrix. Diagonal matrix. What is a diagonal matrix? A diagonal matrix is the one whose diagonal elements are non-zero. Sometimes you see scalar diagonal matrix. Scalar diagonal matrix is a matrix which has a particular number in the diagonal and the non-diagonal is 0. There can be one more example in 3 cross 3 scalar diagonal. So let us write 2 2 2 and say 0 0 0 0 0 0. So diagonal is same and non-diagonal are 0. Such matrix is called scalar diagonal matrix. Fine. Now there's too many. So what we do is, how do we add or subtract any two matrices? Or multiply? Because in matrices also we can add, subtract and multiply. Remember students, we can add any two matrices. Say there is a matrix 1 2 3 4 and I want to add this with 2 3. The addition of these two matrices is not possible because the order is 2 cross 2 and the order is 2 cross 1. To add any two matrices, the order has to be same. Then only we can add the matrices. Similarly, we can subtract two matrices whose order is same. Fine. So if I want to add or subtract any two matrices, the condition is check the order. Okay, so what if I add 1 2 3 plus 4 5 6? Now see, the order is same. We can always add corresponding elements. 1 plus 4 5, 2 plus 5 7, 3 plus 6 9. This is the order is same, and this is the addition, sorry. So if I want to subtract, say I'm taking a 2 cross 2 matrix, 5 6 3 1, and I'm subtracting 1 5 4 0. So what will be the result? So just subtract the corresponding elements. 5 minus 1, that is 4. 6 minus 5, 1. 3 minus 4 minus 1, 1 minus 0, 1. So this is the answer. Now comes a very interesting thing. How do we multiply any two matrices? Okay, multiply. When we multiply any two matrices, do remember that check the two matrices first. Say I have a matrix 2 3 4 1 5 2. So I have taken a matrix of order 2 cross 3, and this is getting multiplied with, say, 5 1 6 2 3 4, and this is 3 cross 2. The order of the matrix is 2 cross 3 and 3 cross 2. Orders are different, but still, students, that we can multiply these two matrices. We can multiply because the column of the first matrix, that is 3, and the row of the second matrix are equal. So we can always multiply the two matrices. The condition is first column and second one's row has to be same, and the result of the matrix will be, first row you see, second column 2 cross 2. This is the result. I repeat again, you can multiply any two matrices provided the rows of the first matrix should match to the columns of the second matrix. Multiplication is possible. The resultant matrix, the result whichever will come as a matrix, will be of the order of first, that is 2, and the last, that is 2 cross 2. So how do we multiply? Multiplication have a very simple technique. I always say running straight, falling down. Use corresponding elements and add. 2 5s are 10, 4 6 are 24, 10 plus 24, 5 3s are 15. Add all this. This comes to 49. Just write 49 here. 2 into 1, 2. 4 into 2, 8. And 5 into 4, 20. This comes as 30. So write 30 here. Then running straight, falling down. 3 5 15. So write 15 here. 1 6 6. 2 3 6. 12 15 27. We can easily multiply, see. And 3 1 3. 1 2 2. 2 4 8. 13. So 13 is the answer. So whenever you want to multiply, just follow rows into columns. You can easily multiply any two matrices. Fine. So sometimes the multiplication is not possible. That I will show you one example. See, if I have question number 2, 2 1 3 4, if I multiply with 1 7 6, then obviously it is 2 cross 2 and it is 1 cross 3. Column is not equal to row, so multiplication is not possible. Column is not equal to row, so multiplication is not possible. That is why we cannot multiply. But it has been seen that 1 2 3 a matrix and 4 5 6 another matrix. If we multiply, this is 3 cross 1, this is 1 cross 3. Since the columns and the row are same, so we can multiply and the result will be 3 cross 3. And see what is the multiplication. 1 into 4, that is 4. 1 into 5, 1 into 6, 2 into 4, 2 into 5, 2 into 6, 3 into 4, 3 into 5, 15, 3 into 6, 18. So this is the answer for multiplication of any two matrices. Fine students, so let us go ahead and understand how can we identify minors, cofactors, adjoint and determinant of a matrix. Here we will understand the inverse also. Minors, cofactors, adjoint, determinant of a matrix. So what we do is, let us understand how to find determinant of a matrix. Say A is a matrix and this A is a matrix of order 2 cross 2. We can find the determinant value of a matrix if it is a square matrix. Say 2 5 7 3. So I am just writing the numbers. How to find its determinant value means the value of the matrix. What is its value? Now what you do is, see the first diagonal, multiply them. 2 into 3 is 6. Always subtract the second diagonal. What is the second diagonal? Second diagonal is this. 7 into 5, 35. So this comes minus 29. So if you want to find the determinant value of a 2 cross 2 matrix, it is first diagonal minus second diagonal. Fine. The similar way we can find the determinant of a 3 cross 3 matrix. Say B is a matrix which has got 3 cross 3 order. Say I'll just write 1 2 3 4 5 6 7 8 9. These are the numbers. I need to find determinant B. See, this matrix also have its position sign. Okay, position sign always starts with plus and keep changing according to its alignment. Adjacent will be just opposite sign, plus minus plus. If it is plus, then minus plus, then it is minus plus minus plus. So this way. So if I write the numbers 1 2 and 3 to start with, 1 2 and 3, 1 will be given positive sign, 2 will be given negative sign, 3 will be given positive sign. Just open the bracket here to write a number. Fine. Now the next very important thing is, what is the row and the column of 1? 1 is in the first row, block it. First column, block it. What do you get? 5 6 8 9. So as you had found the value of this matrix here, similarly follow this. So you know that 9 into 5 is 45, minus 8 6 are 48, 45 minus 48. Fine. So whatever you get, you're gonna write. Now next number is 2. 2's column I have blocked. 2's row we have blocked. We got 4, 6, 7, 9. First diagonal is 9 into 4, 36, minus 7 into 6, 42. Fine. Let's go to the third one. It's 3. The column is blocked and the row is blocked. When we block this, we get 4, 5, 7, 8. So first diagonal is 8 into 4, 32, minus 7 into 5, 35. When we simplify this, we get the determinant value. So 45 minus 48 minus 3 minus 36, 42 minus 6, 2s are plus 12, and this is minus 3, 3 minus 9. So see, minus 12 plus 12, I'm getting 0. The answer for this, the determinant value of this is 0. Okay, so similarly the same answer can be found out using some other row or column. I'll just show you here. Okay, say instead of row 1 I choose column 1, 1, 4, 7. I am finding determinant B, and we are using a green pen to find 1, 4, 7. We expand 1, 4, 7, plus minus plus, plus minus plus, use the bracket. Fine. So when you start with 1, one row and column is blocked. 9, 5, 45 minus 8, 6, 48. So 45 minus 48 was minus 3. I am writing minus 3 here. The second number is 4, so I am blocking 4 row and column. So it is 9 into 2, 18, and 8 into 3, 24. 18 minus 24. Fine. The third one is 7. The column is blocked, row is blocked. 6 into 2, 12, minus 15. So 12 minus 15. So if I write these numbers properly, then you can see it is minus 3. This is minus 6 plus 24. And this is 7 into minus 3 minus 21. I get 0. So every time you can use any row or any column to expand a determinant, to find the determinant of the given matrix. Fine. So the next thing is how to find minors and cofactors. Minors. So let me make you understand first. There is a matrix A. Say the matrix is 1, 2, 3, 4, 5, 7, 6, 3, 2. This is the matrix. Okay, I need to find minors. So before I find the minors, let me tell you the position. This is in the first row, first column, so I can name it as A11. A12 means first row, second column. A13, this is A21, A22, A23, A31, A32, and A33. So if I write M11, M11 denotes the minor of 1, because 1 1 is the position element for this number 1. 1 1 means first row, first column. So M denotes minor of first row, first column, that is 1. So block this 2, we are finding the minor only. 5, 2, 3, 7. 5 into 2, 10, minus 21. So I get 10 minus 21. So whatever I get is minus 11. Similarly, you can find M12, M21, whatever you wish to, you can find. Say A22 is 5. So if I want to find M22, that is the minor of 22, second row, second column, block this, block here, 1362. So 1362, I get 1362. 2 minus 18, this is minus 16 is the minor. Fine. So in this way we can calculate the minors. We are finding what? Minors. We can find the minors of every element. So let us for the last time let us find A33 minor. So M33. M33, we just block this two. 1 2 4 5. 5 minus 8, which is minus 3, is the minor. Now the second topic which we were talking about is cofactors. Cofactors nothing but minus with position sign, plus or minus. That's cofactor. Say if I say C11, C11 is the cofactor of the first element, C11, C11, this is 1 1, M11 was minus 11, okay, but the position sign is positive, so plus. Plus into minus 11 is minus 11. C12, let's find C12. So for that, this is C12. What is M12? Let's block M12. This is 4 into 2, 8 minus 6 7s are 42. 8 minus 42. But you know that the second one is a negative one, because 1 plus 2. Remember how negative and positive comes, that also can be seen from here. 1 plus 2 is 3, 3 is odd, negative. 1 plus 1 is 2, 2 is even, even is positive. So this is 34, it 42. So I get 34 positive because of the position sign. So these are cofactors. Okay, so we have learned minors, cofactors. So similarly we can find the cofactors of all the elements in this matrix. If you want to find C33, obviously M33 was minus 3 and the position is plus, because 3 plus 3 is 6, so answer is minus 3 only. So these are cofactors. So minors, cofactors, and the last topic which we were learning is adjoint. Adjoint of a matrix. Adjoint. See, if I find cofactors of a matrix and I transpose them, it is adjoint. Okay, so say for example I have a matrix A. A is 1 2 3 5. Okay, I want to find the adjoint of A. So what we do is, let us find C11, C12, C21 and C22. C11, C12 are the cofactors of these elements. So if I block 1 1 1 1, then I get 5, and the position is plus, because 1 plus 1 is 2, plus 5. C12, let us write it little far. C12, 1 plus 2 is negative, so 3 is odd. And C12, if I block the second element, I get 3, so minus 3. C21, C21, 2 1 is this, block 2. And since it is odd, so minus 2. C22 is 5, 5 blocked, get 1. 1, C22 is 1. So adjoint of A is nothing but this cofactors. First you write cofactors, 5 minus 3 minus 2 1 should be transposed. Here I want to teach you what is a transpose. Transpose is nothing but just write rows in columns. So 5 Minus 3 is row, so write in columns. Minus 2 and 1 is in the row, write it in the columns. So this is your adjoint of A. So in my next topic, I'm going to make you understand how to find inverse of a matrix using minors, cofactors and adjoint determinant value. So one more thing, inverse of a matrix, A inverse, is nothing but adjoint of A by its determinant value. Fine. So this is A inverse. So let us look for the second video. This inverse of a matrix can be obtained using matrix method and elementary transformation. Both these topics carry 6 marks in your board exams. So please look forward for important questions on matrices by AJ Math Classes. I am your Ajay Pandey, the host, signing off right now. Bye bye, take care.